working in the Spring Framework team. I have been working there for 12 years. I introduced Kotlin support in 2017, quite a long time ago. And I have recently joined the Spring I team, so I split my time between both projects. And today we are going to talk about how to build idiomatic Kotlin application with Spring Boot 4. Does idiomatic code still matters in the age of coding agents? I guess there is various opinions about that. Mine is that if you are building a prototype that you will throw away 2 weeks after, you probably don't care. If you have to live with your project, maintain it, and basically, have maintenance and deal with increasing entropy, etc., you likely want to, for sure, use coding agent, but review your code, take ownership about what you deliver. And I think the guidelines that I will share today, you can learn from them, I guess, as human developers. But also, you can just feed your agent, create some skills. So I will try to share the transcript of this presentation, and you can basically say, OK, create a skills with Sébastien guidelines. You can customize them, and then you can use that. So I think it's both useful for humans and robots. So what kind of build system should you use? I guess the obvious default these days is Gradle Kotlin DSL. You are building a Kotlin project. You can use Kotlin to describe your builds. It is supported on start.spring.io, and I think Gradle consider it as the default that you should use. So it's a non-brainer. That said, so we are generating this kind of default Kotlin DSL configuration. So if you are not sure, even if you are not using start.spring.io, go on start.spring.io, generate a Kotlin project, take inspiration of what is generated. Here you can see that we are generating a Spring Boot 4.1.0 project, not yet released, so wait a bit, or try milestones or release candidates. We are using dependency management plugin. This is an additional plugin that we provide to allow customizing version properties, because Gradle does not provide that out of the box. And we advise to use Java 25. Even if the baseline of Spring Boot 4 is 17, as Jürgen shared in the keynote, we really advise you to use 25 unless you have basically constraints that prevent that. But because it looks like the evolution is going towards declarative build tools. So I'm not saying to use those things today because they are very experimental, but even if Kotlin DSL is the default, and even if it looks like logical to use Kotlin to describe your build in a Kotlin project, both Gradle and JetBrains seems to agree that the future is declarative. Yes, Maven is declarative, but Maven has other limitations. So they are both working on a new declarative incarnation of the build tools for the future. You have Ampere that is using YAML to describe some declarative dependencies and various properties. And you have Gradle, which is working on a new variant, which is declarative Gradle, which is not Groovy, not Kotlin, which is basically it looks like Kotlin, like the syntax is pretty close, but basically it's not a full programming language, because using a full programming language to describe your build has issues, like long time to analyze. When you are doing some small syntax, you have a big pack of red stuff showing in your IDE. So yeah, it's a bit confusing because both are working on different options. So I guess there will be a kind of competition for the future declarative build tool that will be used for Kotlin. But I just wanted to mention that today the default is Gradle Kotlin DSL, use that. But there is some potential more declarative evolution that is coming. And I'm unable to have a strong opinion on either Ampere or declarative Gradle. Maybe at some point they will collaborate, I'm not sure, but yeah, the future looks like declarative. Of course, you should use Spring Boot 4 to build your application, either a new application or upgrade current Spring Boot 3 application. We have recently published the Road to GA blog post that is synthesizing all the big new features. We are talking, for example, about API versioning, Jackson-free support. Spring Boot modularization is surprisingly very important. So see, if you have to read one blog post, read this modularizing Spring Boot, basically the rules of activation of features with the dependencies starters are changing. For the better, it's more explicit, so you will have less side effects, unwanted side effect when you just add a dependency and then some features pop up. So it's now much more explicit. So yeah, this modularizing Spring Boot blog post is really worth to read. For Kotlin, the big news is that we are raising the baseline to Kotlin 2. You could use potentially Kotlin 2 with Spring Boot 3, but it was not really well tested. The dependency management was still using Kotlin 1.x. So now the baseline is Kotlin 2.2. The benefits are faster compilation, better code analysis, better Java interoperability because Kotlin 2 is interpreting natively GSpecified annotation in Java code, and we are going to see that we are providing those GSpecified annotation in Spring Code base, and multi-platform support is much better as well. So the recommendation in terms of version, and this is the default version used by Spring Boot. Spring Boot 4.0 use Kotlin 2.2, Spring Boot 4.1 use Kotlin 2.3, and the upcoming Spring Boot 4.2 that will be released in November 2026, you should use Kotlin 2.4, and this is the default version used in the dependency management. A big reason, and maybe after this slide you will send an email to your colleagues, the big reason to update is that basically Spring Boot 3 will be out of open source support in June 2026, okay? So basically if you have not upgraded, either you take some paid support, happy to help here, but if you want to stay on open source support, by June 2026, you need to upgrade all your Spring Boot workloads to Spring Boot 4. Otherwise, no security fixes published in the, for example, in the open source. So it's very important, and I think this is maybe the biggest reason to upgrade. It's upgrading to new Kotlin version is going to bring also some quality of life improvements, especially if you interact with the JVM ecosystem. And a very popular mistake is that you are using data classes in Kotlin. You are going to use Jakarta validation to just validate some fields, like here, to check an email. You are adding naively this annotation, and then nothing happened. Jakarta validation implementation, like Hibernate Validator, are unable to see this annotation. Why? Because the default translation of this Kotlin code is going to be basically the annotation applied to the constructor parameter, not on the field. And basically, Hibernate Validator, for example, or any Jakarta validation implementation is not designed to watch that. So in every documentation about Kotlin, on Spring, Kotlin side, there is this little tip, okay, make sure to use @field. Basically, you are specifying the target type, so how this Kotlin annotation will translate to the generated code. But yeah, it's not very cool to think about that. It's some noise, and the default should be just, it works. So the good news is that Kotlin 2.2 is introducing a new -x annotation default target equals param property. This is enabled by default if you are generating your project on start.spring.io. And with that, the default rules will be basically, instead of just going to the constructor parameter, is going to be applied to the various target types, targets that are supported. And so here, it will be applied to both the field and the constructor parameter. And the even better news is that this is the default in Kotlin 2.4. So as of Kotlin 2.4, you don't have to care about anything. Hibernate Validator, Jackson annotations, whatever. Java framework is basically relying on this. I want to find the annotation on the field and not on the constructor parameter. It will just work out of the box, no problem. You will be able also to take advantage of the Spring Null-safe APIs. So I think this is the biggest new feature that we are shipping. With Spring Boot 3, we were shipping some null safety annotations, but only Spring Framework and Spring Data were annotated. And there was a lot of limitation. We were not checking consistently those annotation with build time, compiler type analysis. There was a need for an explicit parameter to make Kotlin compiler interpreting the GSR 305 annotations. No proper specification or dependencies, not usable outside of Spring, no generic type nullability. It was very limited. In Spring Boot 4, with GSpecify, we are dramatically improving the scope because every single project from the Spring portfolio is annotated with GSpecify annotation. We are checking everything with null-away, so each project has basically build-time checks to ensure there is full consistency. It has been a huge effort, probably the bigger effort of this new generation. And as of Kotlin 2.1, gspecify annotation are automatically translated to Kotlin null-safety without any kind of weird compiler flag, etc. And generic type nullability is also managed. That means that in practice, with Spring Boot 3, you add these platform types, which means basically Kotlin is unsure about the nullability, so I will be lenient, but maybe there will be some null pointer exception, who knows? And with Spring Boot 4, you have just a nice idiomatic Kotlin API. By default, everything is non-null. And you have basically the translation of gspecify at nullable to Kotlin ? To express the nullability. And this is true for all Spring public API, full portfolio. So I think this is the biggest quality of life improvement for Kotlin developers, because it looks like Spring has been developed with Kotlin. It's still in Java. We are just adding the gspecify annotations. So in practice, if you have a look to the Java doc, you will see that packages are annotated with gspecify annotation null marked, which says default is non-null, and you need to specify explicitly at nullable. When we are not adding any kind of additional annotation in a null mark context, that means that those parameters or return values are non-null, like the Kotlin default, and we are specifying at nullable, which translate to a question mark suffix in Kotlin, and that's done automatically. So yeah, again, it has been a huge amount of work, thanks to the Spring team working on that. It was a bit long and painful, but we are done, and now everything is fine. If you are maintaining some Java library in your organization or company, you can also make them Kotlin friendly, because you can apply the same recipe to your own code. So you can turn your Java API, especially again on libraries. In application, you don't care, but for application libraries used in Kotlin application, you can use the same tricks. So basically, the recipe is first use Spring Boot 4, if you have dependency on Spring. Read gspecify user guide. It's important to understand the semantics, especially related to generic types. Add the gspecify dependency to your application. So it should be API configuration in Gradle or just default scope, compile scope in Maven. It should be a transitive dependency. This is the best practice. Annotate the packages of your library with at null marked to set the default like Kotlin. Everything is non-null by default. And then you annotate fields, method parameters, method return values with at nullable when accurate. And it's a bit more work, but I advise you to use null-away to check the consistency of those annotations across your project, because otherwise you will have mismatch. But if you just want to annotate, it will be fine, and you are just responsible for the consistency of those annotations. WebMVC or WebFlux. I usually get these questions. It's especially popular in Kotlin because a lot of people think that with coroutines you have to use WebFlux, etc. And also the ecosystem is evolving with virtual threads. So I think that's an interesting question. And I'm going to try to provide some default guidelines, some golden path that should be good for most of you. Of course, feel free to choose another thing, but I think this day really WebMVC is recommended for most use cases because we are now with Java 25 that provide a very good virtual thread support, no thread pending issues. It has been fixed in Java 24. Virtual thread is also a good fit. It's not because Kotlin has suspending function and coroutines that virtual thread are bad. It's virtual thread are very good with Kotlin. And WebMVC provide very good support for coroutines and flow. In fact, the reactive adapter that we are using to translate to support Kotlin flow, the very same is used on WebMVC and WebFlux. So of course, WebFlux has more advanced streaming support, and I'm not saying this is exactly the same, but for most of the use case I see, the support that basically using WebMVC with virtual thread enabled in Java 25, and returning flow or using flow or Kotlin extension when you need to use suspending function or flow is the best solution I can recommend. So really that's my recommendation for new workloads. And of course, you can even use web clients in a WebMVC application. It's also possible if you need more advanced streaming capabilities. Another question, because again, Spring provides a lot of choices, so sometimes it can be a bit confusing about which one. Here, programmatic or annotation-based configuration. Java developers seems to prefer annotations because maybe Java is more verbose and provide less nice DSLs than Kotlin. So usually for Java, the default is annotations, but for Kotlin, it's a bit harder. In Kotlin, both are idiomatic. Myself, I tend to prefer programmatic for small application and microservices because I can put explicit configuration, and I tend to prefer annotations for bigger application. That way, the various parts of my application can be discovered automatically without having to wiring things a bit more manually. But, I mean, you don't have to choose, and you can combine them. So if you are using annotations, my main advice would be to do constructor-based injection using this kind of private properties. This will be automatically auto-wired by Spring because there is just one constructor, and so this kind of private immutable property will be auto-wired. So you can combine admin with the router DSL, which is more a programmatic construct, with a Kotlin DSL. So with this kind of syntax, if you prefer to use the router DSL instead of @controller or @rest controller, it's perfectly fine. You can combine both. Programmatic router like that are slightly more performant because you are more explicit about the criteria of your route, so it's really possible. If you want to go the full programmatic DSL-ish way, you can do this kind of thing. So usually, Spring Boot application annotation involves some component scanning that are not needed for a pure DSL-based programmatic configuration. So usually, Spring Boot application annotation is meta-annotated with the annotation that is triggering the scanning, enable auto configuration, and Spring Boot configuration. Here, I'm just using enable auto configuration and Spring Boot configuration to not do any component scanning at startup. I'm importing the programmatic configuration that is going to use bin registrar, which is a new mechanism that we provide the Spring Boot for. And so we just say @import this DSL. This can be applied to any kind of @configuration class. And the DSL is an evolution of the previous iteration. So the new DSL in Spring Boot 4 is bin registrar DSL. The syntax is pretty similar, and here you are going to register various bins using a Kotlin DSL, and that's it. So here, for example, I'm creating a pet management bin with custom injection using a custom builder, and I am registering the various routers that my application is defining. And again, this is basically visible by your application because you are saying @import bins, and bins is defined with that. The router will be typical function-based router, so you will have a function where you are injecting the various dependencies, and then you declare your routes with router DSL, which is here for quite a long time. But this is the true superpower of bin registrar DSL is not just using a Kotlin DSL to declare in a slightly nicer way your bins, is to create your own configuration DSL. And this is the true superpower and key use case for bin registrar and bin registrar DSL. So basically, like I have been providing a Kotlin DSL that basically leverages the Java one, you can create your own custom DSL, providing any kind of domain-specific method that you want to expose. And basically, in the implementation of this method, you are going to register bins with for loops, if statement, and you have much more flexibility than with the @bin configuration. And on user side, you just see that. You don't have to manipulate bin, which is a technical notion. You are just providing a high-level DSL, a bit like Spring Security is doing, and you provide something that is specific to your domain model that will just expose the right level of complexity, and underneath this user type method will do for loop, if statement, call register bin, etc. So I think this is a use case that @bin and @configuration can't do at all. And with that mechanism, you can provide a very powerful mechanism to configure your application. And my hope is that there is more and more Spring libraries that are either using the Java flavor of that or the Kotlin one to provide just expose the right level of flexibility and give more flexibility to the user to do some, again, if statement, for loops, whatever thing they need to do. Okay, logging. This is my opinion about logging. Feel free to use something else, but I don't think, there is not really a good guideline for logging. I have seen people doing various things. There is various libraries that are trying to provide abstraction for Kotlin, but not really one big library that is used everywhere. So maybe we can improve that. So I have not been able to find the perfect thing. So what I would advise for now is to introduce this kind of Kotlin extensions for SLF4J in your project. So here I'm providing a very simple logger for type method that is using a reified type parameter with inline function to basically get a logger of the specified type. You can also provide a version that is automatically going to detect the unclosing class. And you can just use inline function to basically do some conditional logging if the log level is enabled. And I don't think you need much more. With that, you can just create loggers like that, and it will detect the user controller class. Or you can just put your logger outside of the class, just top level in your file. You specify, I tend to prefer this. I'm not a big fan of companion object, to be clear, syntax-wise. You put a top level logger like that, you specify the type, and you are good. So we are currently discussing with the Kotlin team. I would like those extensions to be provided in an official Kotlin library. There is some variation of that in the net, but nothing super official. So basically, we are currently discussing with the Kotlin team to potentially collaborate on introducing official Kotlin library to provide this kind of SLF4J simple extensions, either contributing it to SLF4J or getting a library provided by Kotlin. And my hope is that that will happen, so just not ready yet. So for now, feel free to copy that and include that in your project. Testing. Testing, I'm not going to go too much in details, but something I have really seen is not a lot of people know that you can auto-wire basically class constructors like that. And so I really advise you to just use, so you need to use explicit @auto-wired annotation because GUnit require more explicit signals than regular Spring Beans. So you can inject either the constructor, if you have multiple parameters to inject, or just directly the parameters. And be aware that with Spring Boot 4.2 and Spring Framework 7.1, this kind of construct will be supported with @Mockito bin. So in addition to injecting this kind of regular bin, you will be also able to annotate the constructor parameter to inject the properties with @Mockito bin. Right now, you have to use basically just lazy initialized properties for that. So so this is what I just explained. And you can also use the various extensions that we are providing. So here, expect body with the type here, it's an extension, Kotlin extension. We have been collaborating with the IntelliJ ID team to basically have some automatic int to replace the Java version that is here using expect body, string, class, Java, to basically the more idiomatic Kotlin version. And you have this documentation that is providing basically all the Kotlin extensions. So again, you can basically create an agent skills that say, okay, analyze my code base, check what are all the Kotlin extensions that are provided on this URL, and transform the non-idiomatic Java code to basically the right version of this Kotlin code using extension, and that's it. So I think a skills can be really useful for that kind of automated translation. Should be pretty fast. Okay, Kotlin Serialization got a lot of love in Spring Boot 4. And I think that's pretty cool. There was a lot of issues. So Kotlin Serialization, it's basically an alternative to Jackson 3 to serialize your domain object, serialize, deserialize domain object to and from JSON, and also other formats. Historically, we had a lot of open issues in Spring Framework because there was some by design issues that were not super easy to tackle. So first, there was just no dedicated starter on module in Spring Boot. The Kotlin Serialization support was enabled as soon as Kotlin Serialization was in the class path. And so the Kotlin ecosystem has evolved, and now you can easily get that from transitive dependencies. So basically, you are using Spring Boot, you are adding a dependency, some AI SDK, and then basically Jackson support is replaced by Kotlin Serialization support, and you don't know why, just coming hidden via transitive dependency. So it was quite a big issue. But the biggest issue was basically an overlap with Jackson because Kotlin serialization is mainly designed to serialize classes annotated with @serializable to basically generate code at build time. But it also serializes enums and some Java types, and the rules are not very clear. So there was some kind of overlap where there is no clear signal to know when enable just Kotlin serialization when you have Jackson in the class path. So in Spring Boot 4, we have refined everything. So now you have proper activation via the presence of a Spring Boot Kotlin serialization JSON dependency. This is related to the Spring Boot modularization I was mentioning before. Before, you had activation just with Kotlin serialization in the class path. Now you need a stronger signal, like Spring Boot Kotlin serialization JSON, which is a Spring Boot dependency, which is an explicit signal of basically, please use that thing. There is a dedicated starter, which is just a transitive dependency to the other module. And we have clarified the rule. Now, the default activation of Kotlin serialization is only for classes annotated with @serializable. So if you have enabled both Jackson Free and Kotlin serialization will only take care about serializing the classes annotated with @serializable, which is basically the way of doing things with Kotlin serialization. And Jackson Free will handle the rest. We have a clear boundaries, no overlap, much less issue on Spring Framework bug tracker. And we have been able to support open polymorphism, which was not supported in Spring Boot 3, but now it's supported with Spring Boot 4. Okay, we are now going to talk about persistence and data access for SQL databases. So, yeah. I have bad news for you. Idiomatic GPA is not compatible with Idiomatic Kotlin. We have been working several months with the Kotlin team on that project. We have discussed with GPA experts of all over the world. We have brainstormed, etc. It's a different thing. Like GPA is not designed to work with basically val properties. You can try to do it, but then you will be trapped at some point. And it's really not idiomatic in terms of GPA code. So I think you need to choose. You can totally use GPA with Kotlin, but then you need to follow basically do not use data classes because equals hashcode semantics are not compatible with what GPA advised to do. Use nullable var properties because this is what GPA is basically designed for. And we have been, the Kotlin team has been publishing 2 authoritative blog posts that explain all the details. Maybe you don't believe me, but have a look to those 2 blog posts. They provide a very detailed explanation on why it's not a good idea to use data classes with val properties with GPA. It's very detailed. It's validated by basically Kotlin team, GPA expert, Spring team, and you have all the details there. So I really advise you, if you are using Kotlin with GPA, to read these 2 blog posts. And I think that's fine. I mean, Kotlin is able to adapt to what GPA required. By the way, some constraints that we have with Kotlin data classes, they also apply to Java records. So it's not just a Kotlin issue. It's basically the design of GPA that is done like that, at least regular GPA. If you want to use Kotlin idiomatic code, you can use other persistence mechanisms, Spring Data DDBC, Juke, Exposed. I mean, you have a lot of other options, okay? It's just that you need to accept that basically, if you are using GPA, you need to use constructs that are compatible with basically GPA design guidelines. But yeah, if you can, just use Spring Data JDBC, and you will use your data classes with val properties, and everything will be fine. Another topic and another big source of issues in Spring Framework Bug Tracker, and apologize for that taking so long to fix, but it was basically, yeah, I'm using Coroutines, and basically my context propagation for observability, for example, is broken when I'm using Coroutines, and it's an issue. And basically this is a kind of integration issue that was between Kotlin team, Micrometer team, Spring team, and we had to talk together to find the right solution. It was not that crazy complex, but we had to work on that. And so this is a new feature that is available as of Spring Boot 4. So in Spring Boot 4, you just get automatic support by, of course, adding the Micrometer context propagation dependency. It will likely be already in the transitive dependency of your Spring Boot application if you are using observability, for example. You will configure the Spring Reactor context propagation to auto, because our coroutine support, especially suspending function support, is based on the Reactor 1. And that's it. Basically, observability and tracing will now work in suspending function. You don't have much to do. You will have basically observability or basically logging prefix that will work automatically in suspending function, even if you are using like very complex dispatcher system or customized stuff. If you want to have a deeper look for more advanced use case, you can have a look to this propagation context element class that is on Spring Framework side, is org.springframework.core package. This is what we are using to basically copy to the coroutine context the thread locals or the reactor, basically stuff that are needed to make that work. But yeah, should be good. And the Kotlin team and the Micrometer team are collaborating together to provide, basically, refine the Kotlin support. So I think more improvements are going to come in the future. Okay, Spring AI. So like I said, I have joined recently the Spring AI project. As you know, I'm a big fan of Kotlin, so it's looked like we are going also to provide more Kotlin support. There is already some Kotlin support, and Spring AI is going to, let me talk about that before. So there is an official Spring AI tutorial in Kotlin website, so you can have a look. Currently, it's using Spring AI 1.1 and Spring Boot 3, but it will likely be updated to Spring Boot 4 and Kotlin 2, etc. And so in Spring AI 2.0 that will be released in May 2026, the biggest changes from a Kotlin perspective are the Spring Boot 4 baseline. Okay? We have been annotating the Spring AI project version 2.0 with the very same G-specified notation that we are using elsewhere. So you will get an idiomatic Null-safe API with Spring AI 2.0. That was not the case with 1.1. We have a focus on quality and consistency. So basically, we are doing various refactorings, improving consistencies, improving testing, etc., to have like the best foundation possible. And that will be released in May 2026. In November 2026, you may have seen Christian Zolof's keynote about that. We are going to introduce agentic foundation in Spring AI. It's not specific to Kotlin, but still interesting to Kotlin people, with a new Spring AI agent module that will provide abstraction for agents, goals, workflows, durable workflow support, session API for the persistence part, and we will likely introduce some Kotlin DSL. If you have some needs, feel free to provide me feedbacks on what are the parts where you would expect Kotlin DSL, and we will consider that potentially for 2.1. And 3.0, our goal, and that's pretty ambitious, but we would like to, instead of having the blocking stack and the reactive stack, like WebMVC and WebFlux, the AI world is moving so fast that we would like to have a unified stack based on virtual threads. You may have seen Rosen keynote and talk. There is a part that is not really addressed right now with virtual thread. It's the data streaming. And in AI world, you need streaming. So you need a way to express streaming with structure concurrency and virtual threads. So we are going to try to address that. And Spring AI 3.0 will be at the forefront of leveraging this unified stack based on virtual threads. And we will try to provide adapters to Kotlin Flow. So basically, the goal is that Kotlin Flow is amazing. I think it is the best combination of imperative and declarative API for streaming-oriented features. Java is still very far from providing such capabilities. So I think we will try to provide some adapters to expose those virtual thread-based streaming capabilities to basically Kotlin Flow via Kotlin extensions or basically support in terms of return values. So I guess this is the plan. And last features I would like to present, it's a faster startup with IoT Cache. Again, it's not Kotlin specific, but it's not a feature that is very widely known, so I think it's worth explaining. So Project Leiden is basically a project that is focused on efficiency with a regular Java platform. IoT Cache is a kind of successor for CDS, and basically the goal is to allow you to start your application faster, consume a bit less memory, even if the improvements are less impressive than with GraalVM, and reduce the warm-up of your application. Like you start it and you get peak performance immediately. We are not there yet because IoT Cache is a new feature, but we will get there in a few months. So if you want to enable IoT Cache right now, it's mainly for faster startup time. With Java 25, you get twice faster startup time. And with Java 27 or 28, you will get 5 times faster time, consistent with most applications. So we are not talking about just 10%. We are talking about dividing by 5 the startup time of your application, like end of the year. And so for the current incarnation, the twice faster startup time, you need to use Java 25, the latest LTS. You can use IoT Cache manually, but here I'm going to use buildpack because I can enable it with just one flag, this BP GVM IoT Cache enabled thing. And then when you are building your container image with this single command, what will happen is that basically buildpack is going to do a kind of headless start of your Spring Boot application. IoT Cache is going to record what class are loaded. A cache will be created. It will be injected into your container. And then the container will contain both your application and the IoT Cache. And it will start at least twice faster. And again, in a few months, it will start 5 times faster. There is not yet that much improvement on memory side, so don't expect improvement on that side. But more improvements are coming. You may have seen recently that the compact object headers is going to be enabled by default, probably in the next Java version. 27, I think. That reduces the memory consumption by 10 or 15%. That reduces the CPU, and Project Valhalla and other improvements are going to help reducing the memory. There is also the faster warm-up that is supported as of Java 25. That means that it's not possible with this buildpack integration like that, but you can potentially reduce or remove the warm-up time. You know, you need like a few dozens of seconds or a few minutes to get peak performance with your JVM. IoT Cache, if you are basically creating an IoT Cache from an application running on production, for example, that is serving some workloads, you will be able to say at some point, there is an API that is available as of Java 26 that will be backported to Java 25, which says basically create a cache. Then you get a file, and if you are starting your application with this cache, you will get the faster startup behavior that I shared here, 2x to 5x, but also you will get immediate peak performance, like after 1 or 2 seconds, you will be able to serve peak performance because the profiling information from the production and the native IoT Cache, the native JIT code that will be generated will be in this cache, and so you will basically get the state that, okay, my JVM is already hot, and you can serve peak workload. So that's pretty cool if you want to restart your application with just changing the configuration. If you want to basically scale up super fast, it's possible with both Java and Kotlin, and so I advise you to use this kind of thing. Either the simple flag thing if you want to use our buildpack support, or for more advanced stuff, you need to basically work on deeper integration. Okay, I think we are done, and I can answer to a few questions, and after you can come take this wonderful card if you want. Thanks.